Today we're going to talk about section 2.3. And 2.3 says getting information from a graph of a function. So we're going to get information from a graph. Now, graph of what? Graph of a function. So the things that we're going to talk about today assume that we have a function. For every x, there's one and only one y. So the first thing we're going to look at that we've talked about some before is domain and range. We've talked about the fact that domain is the input into the function. And the domain consists of the values or the numbers that we plug in for x. Okay? So x we know is the horizontal axis, and y is the vertical axis. So this is the x, and this is the y. The height of the graph is the value of the function. So f of x is what we call what we plug into. So f of x is the result we get after plugging in the x. So we call f of x, sometimes we call it y, because we're moving up and down the vertical axis. So we're going to find the domain and the range from a graph. So the first graph we're going to look at is this one. Now I already have it marked here for you, but when we're looking at this particular graph, we know that it starts at 2 over here, curves around, and then comes down to -2. So this right here is my x-axis, and this is my y-axis. So we know that my domain is going to be the things that are on the x-axis. So from 2 to -2, or -2 to 2, depending upon which way we're going to call it. So we're going to say domain is going to be brackets -2 to 2. Now, why do we use brackets? Why don't we use parentheses? The reason why is because we're including this -2 dot and this +2 dot. They're part of that graph. Now, the range is the y values that we're going to use. So the range on this one then, the lowest it goes is 0, because there's no y values down below, and the highest it goes is 2. So our range is going to be from 0 to 2. Again, we've got brackets. So give everybody a chance to catch up to that point first with that graph. Okay, the next one we're going to look at looks like this. Now, what did we call this thing, this curved thing? We've got x squared plus 3, f of x equals x squared plus 3. So what do we know about x squared? X squared is graphing a parabola, so that's what this is. This is a parabola. So the lowest this parabola goes is this point right here. So we know that we're going to consider domain and range now by looking at the graph. It said get information from a graph of the function. We know it's a function because for every vertical line it only crosses in one spot. Later we're going to learn more about transformations, but this +3 on the outside actually moved the parabola up, right? Because when we graphed y equals x squared, it started down here at 0, 0 and did that same curve. So my domain this time is going to be considered to be from the x-axis again. So as this one's going up, it's also going out. So the farther up it goes, the farther out it goes. On this side, same thing. The farther up it goes, the farther out it goes. So if it goes that way forever, because it's got arrows going up, so it's going to continue to go out. So what is that going to say about this? As it keeps going up and up and up, then it's going to go out and out and out. So we know that our domain is going to be negative infinity to infinity. Our range, the lowest it can go and the highest it can go. So the lowest it can go is this point 0, 3. So does it include the 3 or does it not include the 3? Well, it includes the 3. So we know that we're going to have brackets, 3, and then it's going to keep on going up forever with those arrows. So we know that it's going to be negative 3 to positive infinity for the range. Give everybody a chance to catch up to that point first. Okay, the next graph that we're going to look at looks something like this. Now, we have two functions. We have the function going this way, that's g, and we have the function that's coming down here, that's f. So we've got f of x and g of x, graphing of two functions on the same coordinate plane. So now we can use those two functions to find out when f of x and g of x are equal to each other, or when one is greater than the other. So when we look at this graph, we're going to say, where is f of x and g of x the same? Well, they're the same where they cross. So in this case right here, when it crosses at the input of a, right? And so we also know that it crosses up here at b. So that f of x equals g of x are at the values of a and at the x values of b. So in this case, we know that these two things are equal to each other at a and b. Now, g of x is higher than the other one, so we can say that this top part of the graph, the g from a to b, is going to be greater than the a to b on the lower part. So in that case, we can say f of x is less than g of x. So all these ones that are between a and b, and we'd say from a to b. Now, why do we use parentheses instead of brackets? Okay, the reason why we use parentheses instead of brackets is because f of x is not less than g of x at a or at b. The brackets would imply a is one of the things that's in the input, and b with brackets would mean it's in the input. But what do we know about a and b? When it's a and b, then f of x and g of x are equal to each other. Okay, let's try another example. Now, the first thing I want you to look at, though, is just the equations. We see this equation right here, g of x equals 5x plus 6. What kind of an equation do we know that is just by looking at that equation? Well, looking at the picture, we know it's a line. But we knew this was in y equals mx plus b form. The m is the 5 and the b is the 6. So the 5 stands for the slope and the 6 stands for the y-intercept, right? Over here, we have f of x equals 2x squared plus 3. The x squared told us then that we had this parabola. So I want you to get used to looking at an equation and telling me what it's supposed to look like. Now we also know this from your algebra 2, 2x squared. Because the 2 is positive, that tells me that my graph is going to open up. If it was a negative 2, then that would tell me my graph is opening down. Now over here on this one, what do we know about the slope? The slope is 5x, the slope is 5, and it's on the x. So this tells me it's going to be a upward motion on my line. If this was a negative 5, then it would be a downward motion on my line. So all those are things that I want you to be conscious of when you're looking at things like that. So let's see what we know about where f of x is equal to g of x. So what values for x are f of x equal to g of x? Well, it's kind of hard probably for you to see it, but we're looking at the equal is where they're crossing each other, right? These 2 points. So what value of x makes that equal to each other? And over here, what value of x makes them equal to each other? So the question says f of x equals g of x at what x? Well, we know that that's going to be x equals a negative 0.5, and we know that x equals 3. So they're equal to each other at x equal to negative 0.5 and x equals 3. Okay, so what about f of x greater than g of x at what x? All right, so now we're going to look at our graph, and we're going to decide where f of x is the bigger one. So we're looking at where it's going to be greater than, so above the line. So above the line, we start here, what? At negative 1/2, where they were crossing each other. And then the f is above the g, because see how the g is down below here? So this is going to be going from this negative 0.5 and going to the left. So that's going to give us negative infinity to negative 0.5. Now that's only one part where it's above. We also know it's above over here from this dot going up. The g of x is below, so this would be greater than. So the greater than is going to be what? Union with 3 to infinity. Now, we also have the other aspect of where is g of x greater than f of x. So we're going to have g of x greater than f of x. We're going to look at so we're looking for where the g is above. So in this case, the g is above here, so it's between the negative 1/2 and the 3. So it's going to be greater than between negative 0.5 and 3. Okay, let's give everybody a chance to catch up to that point first. Okay, the next thing we're going to do is we're going to find out where a function is equal to 0. Okay, so we're going to start out with our graph. we have f of x equaling x to the third minus 2x squared minus 5x plus 6. So that's going to be our function. And our function is going to look something like this. Now, I want you to, again, we're going to look at the graph and we're going to look at the function and we're going to decide what do we know about this graph. Well, we know that because it starts with x to the third, that it's not going to be a parabola shape, it's going to be the snake shape. So see, we kind of call this a snake shape with its tail coming around like that. We also know that because this is a positive 1 on the x cubed, then we know it's going to start low and go high. So the start low and go high part comes from the fact that this is a positive 1 in the front of the x cubed. Start low and go high. What if this was a negative x to the third? Well, then it would start high and go low. So we're looking at that as being the cubic formulas. Now, the next thing we want to look at is where is f of x equal to 0? So if f of x is the y value, we're looking for where f of x is equal to 0. Those are called the x-intercepts. We're looking for y, where y equals 0, because that's f of x, right? So we look at the graph, and what x values make y equal to 0? Well, we can see that we have negative 2 is equal to 0, positive 1, and a positive 3. So y is equal to 0 at x equal to negative 2, 1, and 3. Now, if I want to write them out in intercepts form, okay, so if I write it out in x-intercepts form, then an x-intercept, we just said y was 0. So we're going to have negative 2, comma 0, positive 1, comma 0, and positive 3, comma 0. This would be the intercepts. Now, we also want to look at this graph and we want to answer another question. We want to answer where x to the third minus 2x squared minus 5x plus 6 is greater than or equal to 0. So we still have this same picture that we're looking at. And we're now saying, where is it greater than or equal to 0? Where is this function bigger than 0 and also equal to 0? So when we look at our graph, we're looking at where y is greater than or equal to 0. Okay? So the y value greater than is going to be above the x-axis, because the x-axis is where it's equal to 0. So this would be the above part, right? But this over here is also above the graph. So in that case, this part right here, between here and between it up. Now, are we going to have parentheses or are we going to have brackets? Well, you can see this says greater than or equal to 0. So greater than or equal to 0 means that it's going to be positive or 0. So positive between negative 2 and 1. So we're going to say brackets negative 2 to 1. Union with, from here we're going brackets 3 and keep on going to the right forever, is going to be my 3 to infinity. Parentheses. Don't forget, parentheses are always, infinity are always parentheses. Okay, so everybody caught up? All right. So the next thing we're going to look at is increasing and decreasing. Remember we said we were talking about things on a graph, looking at functions. Now we know the idea of increasing and decreasing is increasing is going up and decreasing is going down. But the other thing we're going to look at is on our graph. So I'm going to give you another graph to look at. When we look at this graph, we're looking at where it's increasing and decreasing on what interval. Now the on what interval is very important. On what interval. So we're picking off the interval on the x-axis that it goes up and down over this interval, okay? So we know that f of x is increasing, means that at this graph, this is f of x, this curved graph here, so it's increasing from here to here, and it's increasing from here to here. But we don't use the y values, we use the interval that makes up that up and down motion. So between A and B, it's going to be going up, and between C and D, it's also going to be going up. So it's increasing on those two intervals, A to B and C to D. So you got to remember, on what interval means that you always pick it up off of the x-axis. Now, notice that I've been using parentheses, but some books will use brackets for increasing and decreasing. Some books say it's not increase, you don't have a filled in dot, or you don't have brackets because at that dot it's not increasing or decreasing, it's just there. Some people use brackets, so just be aware that which textbook you have. So we're going to use the idea of the parentheses for increasing and decreasing. Okay, so we're going to look at another graph. It has some numbers on there. Okay, and we're going to give it a function name. Sorry, about to run off the page there. All right, so we're looking at this function. Now, before we go ahead and figure out where it's increasing or decreasing, the first thing we're going to do is talk about what the picture looks like. But before we can do that, we have to write this in what we call descending exponential order. So we start with the highest exponent and go down. So we're going to have f of x equals, this is going to be negative 3x to the fourth plus 4x to the third plus 12x squared. Now, remember we talked about before, we said that if it had been a cubed, then it would have gone low to high or high to low. This one is the fourth power. So fourth power has that kind of parabola again, where we either go down, down, or up, up. Because it's a negative 3, we're going to go down and down. If it had been a positive 3, then we would have been up to up. Now, it does this extra movement in the middle of it, so it's not a parabola. But that fourth power is an even power. So if it's an even power, it's going to have that up, up, or down, down. And if it's an odd power, like we did before with the cube, then it's going to be the snake-looking shape. So we're going to write down where it's increasing and decreasing. So first one, we're going to have I for increasing. So we're looking at where it's increasing. Well, in this first one, we have going from here, we always start from the left, like reading a book. That would be arrowing, but it's going to continue to go out that way forever. So what would that be? It would continuously be increasing up to what? -1. See how this -1 up here, and then it starts going back down again? So the -1 is going to be my starting point going this way. So we're going to have increasing from negative infinity to negative 1. Okay, where else is it going to be increasing from? Now remember, we don't use the 10, 20, 30, 40. We use the interval off the x-axis. So what is it going to be increasing on? It's going to be increasing from 0, and it's going to keep going up and up and up until we get to 2, where it starts coming back down again. So we're going to have between 0 and 2 is another place it's increasing. All right, now I'm going to give you a few minutes to see what you think for decreasing is going to look like. So where is it going to be decreasing? Okay, so we're ready for decreasing? Well, we know that from negative 1 to 0, so this would be 0, it's going to be going down. On the x-axis is where we get our intervals from. So we've got negative 1 to 0, it's going down. But we also know that we go up until we get to 2, but then starting at 2, it starts going back down again, and then it has an arrow, so that means it goes forever. So the other part of it's going to be from 2 to infinity. So that's increasing and decreasing. Make sure we use the intervals that's on the x-axis. Okay, everybody caught up? Okay, the next thing we're going to look at on the graph is the maximum and minimum. We're going to actually look at what we call the local maxima and local minimum. So we're going to look at an example. So basically all we're saying for local maxima and local minima is the high points. So you've got a high point here and you've got a high point here. Localized kind of is what we're talking about when we say local. It's within that particular area. Between this particular area you have a high point. Here we have a low point, so there would be the minima, and here's another low point, that would be a minima. So I'm going to give you one that has some numbers on it, but we don't have the calculators right now, so we'll get calculators in a little bit. But, excuse me. When we write it, we're going to write, when we talk about a maxima, here would be a maxima, and here would be a minima, right? So we have a local maxima at, this is 10, 20, so the exact value, if we were using a calculator, would be a maxima of 9.71. And notice here how this would be negative 1, because this is negative 1, negative 2, negative 3, negative 4, negative 5, right? So this axis is going by 1s, and this axis is going by 10s. So they tell us that the high point is going to be the 9.71. So we write it as 9.71 at x equals negative 1.63. Now, again, we'll find out how to find those on a calculator, but for right now, I just want you to get the idea of how to write it. So we're going to have a maxima of 9.71 at x equals negative 1.63. So we're okay? Everybody caught up? Thank you very much.